Guys, so today we are back with another problem, the reverse level order traversal. So I hope this is 7th May, so it might be the, let me check the number of days, 1, 2, 3, 4, 5, 6, 7. So it might be the last day we are doing binary search tree problems of today, and also there will be lot of other problems coming over next week. Let's see. So what is about today's problem? So today's problem is reverse level order traversal, where we will be given a binary tree and we have to return the array list of that tree in reverse order. It's basically very simple. If you see, there is a binary tree. First they are returning 40, 60, 20, 30 and 10. So they are step by step they are returning the traversal in reverse format in an array list. So before knowing how the reverse traversal works, we have to know the concept of queue data structure. So in queue data structure, what happens is it is an interface that represents a collection designed for holding elements prior to processing. It follows the FIFO, which is a first in first out principle, meaning that the elements are inserted at the end and removed from the beginning. So it's like you have a bottle and you have to enter the elements from the end of the bottle, and you have to take out from the cap of the bottle. So that is first in first out. You have to enter the elements at the end and remove from the beginning. So the queue interface extends the collection interface, which provides additional methods for adding, removing and inspecting elements. I would give a brief introduction about some of the queue element structures, which is offer, pole and peak. Offer is used for inserting the element into the queue. If it is possible, do so immediately without violating the capacity restrictions and all those things. Pole retrieves and removes the head of the. So pole command we use when we want to retrieve and remove the head of the queue. Okay, and peak retrieves but does not remove. So these are some of the functions. You can take a screenshot or you can write it in your notebook for better understanding of how queue data structure works in linked list. So what basically we are going to do is, over here we are going to, as usual, we will create a resultant array list. So array list of type integer, I will take, say, result equals to new array list. Okay, so once the resultant array list is being taken, I am going to check the root condition. If the root equals to null, so if there is no elements present in the array list, we will return the resultant array list. Okay, this was our first step. Second, we are going to determine the queue data structure. So QUEUE, the spelling often gets confused. We have to take node parameters. Say name of the function is Q1 equals to new linked list. Yeah, so we have taken the Q1 as the queue data structures. In that Q1, what we are going to do is first Q1 dot offer root. So what is basically this is doing? You can see I have written the logics. It inserts specified elements into the queue. So we are inserting specified elements into the queue. Once the insert elements are being inserted, we are going to start a BFS traversal logic, which is breadth first search. So in breadth first search, we will check, the loop will run until the queue is empty. So dot Q1 is empty. So empty will run the loop. So not, yeah, in this while loop, what we are going to define a new node equals to QUEUE dot pole. So what pole will basically do is, we have already given the definition that pole retrieves and removes the head of the queue data structure. So if you try to do pole retrieve and remove the head of the queue data structure. So once we have taken the pole elements, we were going to add it into our result or final array list. So result dot add 0, node dot data. So why we are using 0? We are going to pretend that last is first, because you can see the reverse order traversal you have to do. You cannot write 1, 2 and 3 or 1, 3 and 2. You have to write 3, 2, 1. So this is used to pretend the last is first. So node.00 denotes the first element, is result.add, because whenever you're adding elements to the linked list, it is added from the reverse, like that. So if node not, so now we are going to individually check whether the node write has a value or not. So node dot write, I have done this in my previous problems as well, not equals to null, means it has a value. So what I will do, q1 dot offer node dot write. Similarly, I will check for node dot left has a value or not. So not equals to null means it has a value. So q1 dot offer node dot left. So whenever you're checking it is not null, means it has a value. Again, it is not null, so it has a value. So add right elements. Similarly, add left elements. When the elements are being added, what we can do is we can return the result. So we can compile. So if root, so the name of the data structure is node, so I have to take it as node. So node, let's check. I have to put a dot, compile. So I can take this as root, since the same value I cannot take multiple times. So I will take it as root. Now I will try. Cannot find symbol. Node equals to q dot poll, q1 dot poll. Now let's check. So yeah, we have successfully completed this code. So I can run over here, returns reversed linked list. So we got 8 gig big points. Looking forward to see you in our next video. Take a screenshot of this one if you find it easy and comfortable. Thank you.